Hello and welcome to the video on mouseX, mouseY, and the random function. If you are interested in following along with this video, I strongly recommend you pause now and open up a P5 editor so that you can code along. If not, feel free to watch, pause, try, come back to this as a reference whenever you need to. Again, we're going to be covering the random function and how to utilize that in your program. We are also going to be discussing how you can utilize mouseX and mouseY. Now, I already have a partially set up program on my screen, and just to walk you through it, if you would like to set this up on your own as well, I have given the color mode as HSB, which, if you don't understand this, there is a video on additive and subtractive mixing and swapping between color modes that you may want to watch. I have added two lines right after my background, one that creates text using the mouse coordinates, so we can see in the upper left corner of the canvas, you see these numbers that change as my mouse moves around the screen, and then we also see this fill, which is currently set to black. The last thing I have is a circle with a fill. The color's a little arbitrary, you could have whatever you want. And then the ellipse is just in the middle of my screen, nice and big. Again, this is something you could change if you wanted to. So the first thing I'm going to show you is what the random function looks like, and to do this I'm actually going to make my circle a little smaller. I'm going to make it about 100. And what random does is it picks a random number in a certain range. So before we start using random, I am just going to show you using this cool thing called console.log. Console.log is a function that makes something print to the console, which is this gray space down below where you might have seen errors before. The console doesn't necessarily affect what's happening on your canvas, but it is a great place to get a little feedback of things that are otherwise hidden from you by the computer. So I'm going to console log random 5. And notice random is a function, so it has these parentheses that need to close. The argument for random goes inside of those, and then console.log is also a function, so it has parentheses that need to close as well. One useful thing for debugging is you can see when I click near a parenthesis, it boxes that parentheses partner. So if you ever have an error that you have like an unexpected end of input or an extra parenthesis, this can be a really useful way to figure out where those things are happening. So I'm going to hit play a few times, and I'm just going to pay attention to what's printing out in my canvas. So I have 1.96 something something something, now I have 3.17, now I have 2.0, and we can see from this that every single time I'm getting a random number, and every single time that random number is like a really long decimal. And that is because it's doing exactly what I asked it to do. It's picking a random number between 0 and 5, and those random numbers are not destined to just be integers. For our purposes in a program, it's totally fine if we want to use these decimal values for most of what we'd be doing in programming, but if it is something that bothers us, we can wrap this whole thing in an int function, which will turn whatever number we are given into an integer. So now when I hit play, I see that I get values like 1, 4, 3, and I could also adjust this number to maybe be out of 100, so now I have even more values that I could get. Lots of options here on how to use what random will give us. Now, randomization encoding can allow for some really cool effects. It can also be used if we were doing something a little bit more game-oriented. Randomness is a lot of how you would decide, like, who wins a turn or how much damage your character takes. And if that's something you're interested in pursuing, that's definitely something you would be able to do throughout this course. But to start us off, we are just going to talk about getting a random value, saving a random value, and using a random value. So anytime we want to save a random value, we are going to need to be able to make a variable. And I suggest that for most variables you make in this program, you make them as what we call a global variable, meaning they can be used in any function, setup, or draw. To make a global variable, you will declare your variable above the setup and draw function. I like to do it like at line 1, just start at the top. And you always declare a variable with either the word var, V-A-R, or the word let, L-E-T. For your purposes, var and let are very, very similar. Let is a little bit of a newer functionality, but I think var, which still works in all JavaScript frameworks and browsers, is a great option for new learners because var sounds like variable. So that's what I'm going to stick with in this program. When you make your variable, remember that it can be any word. The best practice for programmers is that it is lowercase and camel-cased, meaning the first word is lowercase and the second word starts with an uppercase letter. Variables cannot have spaces in them, it will not work. Variables also cannot be what we call reserved words. So on my screen I see setup, create canvas, color mode, HSB, draw, background, fill, text. Those are all reserved words, meaning the computer already knows what those do. In order to make a variable, I need a brand new word that the computer is not going to be aware of. And in this instance, I think I want my variable to control maybe the position of my circle, maybe the X position of my circle. So I'm just going to call this XPOS. And notice I'm camel casing. This P that stands for position is capitalized and the X is lowercase. It is not wrong if you start with an uppercase letter. It is just not what most programmers are used to seeing. So if you were doing this in an industry standard setting, people would be confused why you were capitalizing your variables. So the next step, once I have my variable, is I need to assign it a value, and I'm going to assign it a value inside setup to start. Assigning things inside setup is a great practice because it gives them a starting value before that variable is used, and it makes sure that you're not going to get weird errors about the variable not having any value. Inside of setup, I'm going to write XPOS equals, and then I'm going to give it a random value between 0 and 400. And notice before, I was just typing 400. That's also totally fine. This will default to between 0 and 400. I can also set a range, so maybe I only wanted it to be between 100 and 400. Doing 100, 400 will allow that to happen. I'm going to revert this back to just 400, and then I'm going to go down and I'm going to use this variable. I'm going to plug it into the X position of my ellipse, and now when I hit play, we're going to see that my circle, every time I hit play, is at a new place in my x-axis. And that's because every single time this XPOS variable is being given a new random value. Now I could also do this for the y position. I could say that YPOS is equal to a random number also between 400 or 300 or whatever number I want. I could plug this in here. And then we will see that every single time my circle moves to just a brand new place on the canvas. It gets a new X and it gets a new Y, and that is entirely random and unpredictable. You can use these variables and this random function for anything that takes a value. So you could make a variable, or you could utilize random in background, in fill, for size, for position, anything that is a number, it will take these values in. One thing that I do recommend is that you make sure students understand why you are putting it in setup versus draw. You can absolutely do the same thing we did in setup in the draw function, and I'm going to show you that in just a second. I just commented out these two lines so that I can show you this. One thing we need to remember is that the setup function only runs one time at the very beginning of the program, whereas the draw function is on an endless loop forever and ever and ever. So in this program, on lines 8 and 9, we are picking one random number, and that is the random number that exists the entire time draw is running. If we were to put these variable initializations in my draw function, every time the draw loop runs, it's going to pick a new random value. Before I hit play, this is the place where I would warn people if you have any type of motion sensitivity, things that might trigger seizures or things that you otherwise should not see quickly flashing objects on the screen, please fast forward a bit because this is going to get a little jarring. If you demonstrate this with students, this is also something I would recommend just naming to them before you hit play. So when I hit play this way, we see that we have a circle flashing all over the screen because every time this draw function runs, it gets a new position. And the draw function runs about 60 times every second. So we are getting a lot of new positions. Some people think this is a really cool effect. For some people, it's like absolutely nauseating, and it's not something that they should look at. So this is something that students as designers should think of mindfully as they are selecting what they want to control. But at its base, that is the random function. You will see this throughout the year. It is always a handy thing to have in your back pocket. The other thing that is really useful is figuring out how to utilize mouseX and mouseY, which you are seeing used in this text function on line 15. They are the reason that as I move my mouse around the screen, I am able to see the numbers where my mouse is at any given moment. mouseX and mouseY are what we call system variables, and we will spend more time talking about these, but they are variables that are built into P5 to automatically get and gather information about the computer system you are using. You do not need to declare them like we did here on lines 1 and 2. You do not need to initialize them with a value like we did on lines 8 and 9. You just need to plug them in, and the computer is going to do all of the parsing and assignment of information for you. So just like random, mouseX and mouseY hold a number. Something that we are going to figure out is that everything in computing is a number, even though sometimes those numbers represent other things. And if I were to plug mouseX or mouseY in somewhere in my program, whatever number I am getting for mouseX and mouseY would become that number in my program. So I'll use this to change the fill of my circle. I'm going to plug mouseX in for the hue of my color. And now when I start this program, we see that my circle starts at red. As I move my mouse left to right across the screen, you will see this color shift through the entire spectrum until it gets back to red once I'm at the edge of my screen. I could also use mouseY to control something like maybe saturation. Oops, mouseY. And now as I go up and down, my circle will get more or less vivid. It'll kind of go from pastel to really bright, and then it will go dark to light. Notice that my vividness, my saturation, is a little limited. Saturation generally is only programmed to go from 0 to 100. So once we pass 100 on the Y, we're like pretty tapped out. We're not actually making any changes after that point. If this is something we want to happen more subtly throughout the whole program, we would need to use the map function, which is something you'll be getting a video for later in the week. We can again use mouseX and mouseY to control just about anything in our program, including size of our circle. So now not only will it change color, but as I move down the page, it will also get bigger. I would strongly encourage you to explore how you think you could use these in other ways, shapes, and forms. I want to see what interesting results you get. If you get something cool, please make sure you share it in the Slack or come to office hours to show it off. We'll talk to you later. Bye.